Okay, let us see the importance of frequency control. So this importance of frequency control under the real power compensation control. That means the load frequency control mechanism of a single control area. We have a single control area and double control area. The load frequency control mechanism of a single control area is first described. Then multi-area control system are extended. So if tie-line bias control of a multi-area frequency control system, always importance of frequency control. The frequency of a power system dependent on a real power balance. Real power is important power. So the frequency of a power system always depend on a real power balance. A change in real power demand at one point of a network is reflected throughout the system by a change in frequency. So due to this condition, the system frequency provides a useful index to indicate system generation and load imbalance. Okay, this is simple conversation of power system, real power importance of frequency control. Active power and frequency control are known as essential ancillary service that should be provided by generation units in large power plants. This is not applicable in small power plants, it's applicable only in large power plants. So controlling these type of grid interactive power plant in critical issues to achieve large scale integration of renewable energy system. So renewable energy system is one of uh, important distributed system like wind PV are dependent on weather condition and geographic location, and their stochastic behavior can significantly influence power system performance. These effects will be more relevant in case of large scale penetration of renewable energy system. Therefore, this active power and frequency control always depends the modern power plant based on renewable energy system. It should both deliver power as conventional generator and contribute to support the grid services by providing ancillary service. So active power and frequency control always consequence one. So this control is most preferable based upon closed loop system. So a frequency of a system is dependent on active power balance. A change in active power demand at one point is reflected throughout the system by a change in frequency. The control of generation and frequency is commonly referred to as load frequency control, having two classification. One is primary and secondary speed control action. Primary action based upon speed governing, secondary action based upon automatic generation control AGS. Shortly we call AGS, and load frequency control LFC. So those two categories is under the control of speed control action in active power. So let us see the speed governing of primary action. So speed governing having some fundamental criteria. Governing system defined as combination of devices and mechanism which sense speed and power deviation and convert them to a servo motor, stroke or gate positional signal. So according this explanation, governing system each and every minute regulate the turbine speed, then turbine power and participate in the grid frequency regulation. So these are explanation says fundamentals of speed governing system. Next, we are seeing major points of speed governing. So it consisting three major points: modeling of equipments, generator response to load change, load response to frequency deviations. So how the power system operation will control by this modeling of equipment mean some specific criteria there, that specific diagrammatical representation, note it on the generator supplying isolated load diagram on mention this PPT. Look at this PPT. So initially steam or water get into the valve gate. The valve gate is needed to allow or stop the entering various kind of input. Here steam or water is input. So apart from steam or water, some other input also get into the valve gate. So valve and gate having some sensor to enter or not enter into the turbine. So this facility is inbuilt in valve and gate. Okay, this input or steam or water enter into the turbine. Turbine rotate fastly. Parallelly, the turbine produce motor torque and electrical torque, mechanical torque and electrical torque parallelly, and which is going to reach generator set. Generator provide proper electrical input based upon PE. So this electrical input having to reach load PL. This is cyclic process. Uh, According the turbine action, the turbine output, that means speed sensed by the governor system. The governor system receive that turbine output and get into the valve gate. This valve gate compare the input of steam or water and the governor output parallelly. So after comparison, valve and gate give a proper input to the turbine system. This is cyclic process. T suffix M is mechanical power, T suffix E is electrical torque, PM is mechanical power, P is electrical power, PL is load power. This is modeling diagram of equipment.